Have you ever wondered why chi-square tests hold such a critical role in medical research? Well, to unwrap this enigma, it's essential to acknowledge that medical research often deals with categorical data. This data, whether it's the presence or absence of a disease, patient's response to a treatment, or the distribution of blood types in a population, often requires a statistical test that can compare observed frequencies with expected ones. And here, my friends, is where the chi-square test steps in. The chi-square test is a statistical tool used to determine if there's a significant association between two categorical variables. It's a test of independence that helps researchers draw conclusions from the data they've collected. But how does one actually do a chi-square test? Well, brace yourselves, as the journey to understanding this isn't as daunting as it might seem. Step 1. Identify your variables. This means you need to identify the categorical variables you are interested in. They could be anything from patients' responses to a drug to the prevalence of a disease in different age groups. Step 2. Observe your frequencies. This involves collecting data and counting the number of times each category occurs. Remember, the more data you have, the more reliable your results will be. Step 3. Calculate the expected frequencies. This is done by multiplying the row total for a category by the column total, then dividing by the total number of observations. Step 4. Compute the chi-square statistic. Subtract the expected frequency from the observed frequency, square the result, and then divide by the expected frequency. Do this for each cell in your table, and then add all these values together. This will give you the chi-square statistic. Step 5. Determine the degrees of freedom. This is calculated by subtracting 1 from the number of rows and columns in your table, and then multiplying these two numbers together. The final step, step 6, is to interpret the results. Compare your calculated chi-square statistic with the critical value from the chi-square distribution table. If your calculated value is greater than the critical value, then you can conclude that there is a significant association between your variables. To summarize, performing a chi-square test involves 6 key steps: identifying your variables, observing your frequencies, calculating the expected frequencies, computing the chi-square statistic, determining the degrees of freedom, and finally interpreting the results. Though it might seem a bit complex at first, with practice, the chi-square test will become a handy tool in your medical research arsenal. It's a robust method to validate your observations and assist you in making meaningful conclusions from your data. So keep practicing, keep learning, and keep pushing the boundaries of your understanding. Because remember, every piece of data holds a story, and it's up to you to unravel it.